In this video, we are looking at the examples on page 3 of the Chapter 2, Section 3 slides. We're starting off with this equation. These are both, these two problems have an infinite number of solutions. So we're going to solve this linear system as best we can. So this becomes the matrix 1, 2, 4, 3, 6, 12. Well, we've got that 1 up in the upper left corner, and that's great, because it means that we can just subtract 3 row 1 from row 2. Okay, and that's going to give us 1, 2, 4, stays the same. 3 minus 3 times 1 is 0. 6 minus 3 times 2 is 0. And 12 minus 3 times 4 is 0. So what we're saying here is that we don't know. We don't have a specific solution. What we have is an infinite set of solutions given by x plus 2y equals 4. Or we could also write that as x equals 4 minus 2y. Or we can solve for y and get y equals negative 1/2 x plus 2. Any of those is correct. But the important thing here is that we have our values for y and x depend on each other. There is no single solution. Moving on, we've got one in 3 variables. So we set up our matrix as always. And we get x plus, should be doing this with our coefficients. We've got 1, 2, negative 3, negative 12, 3, negative 1, negative 2, 1, 2, 3, negative 5, negative 3. Okay, well, then our first step is going to be to eliminate our 3 from row 2 and our 2 from row 3. So we'll take row 2 minus 3r1 and row 3 minus 2r1. This gives us 1, 2, negative 3, negative 12. That's not going to change. 0, negative 1 minus 3 times 2. That's negative 1 minus 6 is negative 7. Negative 2 minus 3 times negative 3, so that's negative 2 plus 9 is 7. And then we've got 1 minus 3 times negative 12. So it's 1 plus 36 is 37. Now we subtract 2 row 1 from row 3. So 2 minus 2 is 0. 3 minus 4 is negative 1. And negative 5 plus 6 is positive 1. Negative 3 plus 24 is 21. Okay, so I think I did something wrong in row 2 there. Just see something here. Yes, I did something wrong here, which is messing us up. That is supposed to be a negative 2. And that will fix things a good bit. Negative 2, negative 2. So then when I subtract 3 times negative 2 from 1, or rather add 6, yeah, so we're going to add 6 to 1, it's negative 2, that's 7, much better. And we've got negative 3 plus 4 is 1. We like that. That's a lot better. Okay, well then. Now we're going to divide row 2 by negative 1/2. Or sorry, we're going to multiply it by negative 1/2. Which will give us 1, 2, negative 3, negative 2. That stays the same. 0, sorry, that should be negative 1/7. Everything there is a 7, so we want 1/7. 0, 1, negative 1, negative 1, and 0, negative 1, 1, 1. Great. We're in good shape there. Now we can add row 3 to row 2. So we get, and we can add 2, subtract 2 row 2 from row 1. So row 1 minus 2 row 2, and row 3 minus plus row 2. This gives us 1, 2, no, sorry. Okay. 2 minus 1, 2 times 1 is going to be 0. Negative 3 minus 2 times negative 1 is negative 1. And negative 2 minus 2 times negative 1 is 0. Row 2 remains the same, 0, 1, negative 1, negative 1. And finally, row 3 gets canceled out. So what does this tell us? This tells us a bunch of stuff. It tells us first that, remember, this is the x column, the y column, and the z column. Well, this says that x minus z equals 0, and y minus z equals negative 1. Well, that means x equals z. And it means that y equals z minus 1, which is equal to x minus 1. So there we go. We get a lot of information out of that, and we get a key to all of the solutions to this system. But there are infinite solutions. We can't find just one. If you have any questions, let me know.